In this question, you will investigate the areas of trapeziums. The parabola y equals to x multiplied by 2 minus x is shown in the graph below. Alright, remember we studied this in the quadratic equations topic. I told you all that whenever you have a parabola that's shaped like this, a negative shaped parabola, it means that we have a minus sign before the x squared, right?
Yeah.
Yeah. So what do we have in this case? Essentially speaking, the equation of this parabola can be written like this: 2x minus x squared, like this, basically. Write down the missing values in the table. So, the longer base of the trapezium for each stage, here this is positive 2 again, positive 2, and then you have 12 and 14. That was the missing value in the table.
Right.
Then it says describe in words two patterns for it. First things first, there is a term to term pattern. Firstly, what is it? That is that as the stage number increases, as the n increases, value of L increases by 2. Another pattern that we can see is all of the numbers are even numbers. All of the numbers are multiples of 2. So we can say each number is even and is multiple of 2. Another pattern that I just noticed, that's like, it's not important to write this down, but I'll just write it. If we multiply 1 with 2 and then add 2 to it, we get an answer of 4. If we multiply 2 with 2 and then add 2 to it, we get an answer of 6. If we multiply 3 with 2 and get an answer and add 2 to it, so we get an answer of 8. So I can say that the value of L is basically the sum of 2 and the product of 3 and 2. Another thing that I can add to it, L is the result of the sum of 2 and product of 2 and 3. That's another thing that we can add to it. Not necessary, but it's up to the student, of course. Write this down and tell me once you're done. Then we are told write down a general rule for L in terms of N. So the difference that we have is 4, 6, 8, 10, 12, 14, so on and so forth, right? So what sort of a pattern do we have in our case? We can say that since it's a linear pattern, the equation should be a plus n minus 1 multiplied by d. The first term is 4 and n minus 1 multiplied by d. The common difference is going to be an addition of positive 2. So I'm left with 4 plus 2n minus 2. That becomes 2n plus 2. That is going to be our general rule, 2n plus 2. Make sense?
Yep.
That's great.
I wrote that part down already.
That's great. The next part is of course going to be of verifying your general rule. So that's very easy as well. What we can do is that we can substitute the values n equals to 2 and n equals to 5. So 2 multiplied by 2 plus 2 gives me an answer of 6. 2 multiplied by 5 plus 2 gives me an answer of 12. Alright, so I can say hence my value is proven since it matches the column in table. So that would be the right answer. Okay,
Right. I wrote that down.
that's great. So should we solve the last part then? Part E?
Yeah.
Alright. Investigate the values in the table and find a relationship for the area of the trapeziums in terms of n. Alright. So we have 4, 6, 8, 10, and of course the next value is going to be 12 and 14. For the smaller base, we have a linear difference as well. 2, 4, 6, 8, then we have 10, then we have 12. For the height, we have 3, 5, 7, 9, and the next one is going to definitely become 11 and then 13. For the area. Now, area in stage 1 is 9. And then the next value of the area in stage 2 is 25. Then there is 49. So what can we see? We can see the pattern of square numbers being formed, and this is by far the most common one in your IB MYP syllabus. So 9 can be written as 3 square, 25 can be written as 5 squared, 49 can be written as 7 squared, 81 can be written as 9 squared. So the next two areas should be 11 squared and 13 squared, right?
Yeah.
So 11 squared is 121 and 13 squared is 169. So we are done with the part of prediction for each and every value. Write this down and tell me once you're done writing. Like make it your own way. Of course, you're not going to make the entire table, but do it to the best of what you can. I'll be back.
I finished writing it.
That's fine. Give me a second, please. There's some sort of a
Hmm?
problem at my end. I'll just have to move from my place. So, what do we have next? Describe in words a pattern for column A. So, one pattern needs to be described. So, we can say that the area of A is basically equal to the square of the height. Area is equal to square of H. That's going to be as simple as it can be. Determine a general rule for A in terms of N. So have a look. It's not saying A generally. It's saying A in terms of N. So how is that different as compared to the questions that we had solved? So our area is 9, 25, 49, 81, 121. The difference between 9 and 25 is of 16. 25 and 49 is 24. 49 and 81 is 32. 81 and 121 is 40. The difference between 16 and 24, however, is 8, 8 again, and 8 again. So we are having our set of common differences present. So I can say that the value of 2a is equals to 8, which means the value of a is going to be 4. 3a plus b equals 16. So 3 into 4 plus b should be equal to 16. So 3 times 4 is 12, and 12 plus b equals 16. So b equals to positive 4. And I know that a plus b plus c should be equal to 9. 4 plus 4 plus c equals 9. 8 plus c equals 9. C equals 9 minus 8, which is positive 1. So the equation that I have is 4n square plus 4n plus 1. Alright? I hope this makes complete sense to you. Write this down.
I wrote it down.
Okay, that's great. Can you verify it and justify it as well? Not justify, just test and verify it and tell me if you're getting the same answers. So if you were to test it, for the value of n equals to 2, 4 into 2 square plus 4 multiplied by 2 plus 1. 2 square is going to be 4, and 4 times 4 is 16. 16 plus 8 plus 1. This gives me an answer of wait a second. Have I done something wrong? For the value of n equals to 2, that becomes 25. But I'm not getting that answer. Yeah, okay. Yeah, I'm getting that. N equals to 2. So yeah, I'm getting an answer of 25. For the verification part, in order to verify this can be solved in this way. Let's consider the value of n equals 5. 4 into 5 square plus 4 into 5 plus 1. 5 square is 25, and 25 times 4 is 100. 4 times 5 is 20, and 20 plus 1 is 121. So that is the testing and the verification part completed. So the testing and verification part, or the justification part in fact, Let's substitute the expressions for the length and the side. I know how is a trapezium found? It's 1 over 2 multiplied by sum of parallel sides, which is a plus b multiplied by its vertical height. Now the sum of the parallel sides are being represented by L and S, right? So I can write this as 1 over 2 multiplied by L plus S multiplied by h of height, whatever it is. So essentially, what do I have? L plus S over 2 multiplied by h is another way of writing it, right? That's another way of writing the same thing down. Now I know that height essentially, if you square the height, that becomes the area. Okay. What about the values of L and S? Is there a pattern that is followed there as well? We have to, in order to find that, we have to find first the base length. And then we have to multiply this by the height of h. So, for the value of h, focusing on the values of h, 3 plus 5, sorry, not 3 plus 5, rather, in the first case we have 3, then we have 5, then we have 7, then we have 9, so on and so forth. If you were supposed to find the nth term of this expression, you will get an answer of 2n plus 1, right? Let's prove it. 3 plus n minus 1 multiplied by the difference of positive 2. So 3 plus 2n minus 2. 2n, 3 minus 2 becomes positive 1. 3n plus 1. 2n plus 1, my bad. Now, I know that if I was to square this value of height, I would get the area. And I am supposed to justify the equation that I had of 4n square plus 4n plus 1. So if I square 2n plus 1, if I whole square 2n plus 1, what would I get? 2n multiplied by 2n gives me 4n squared. 2n plus 1 gives me 2n. 1 plus 2n gives me 2n. And 1 plus 1 gives me 1.